So let's continue talking about important object-oriented concepts as a precursor to introducing the Unified Modeling Language, UML. Well, we showed you in the last video a class is just a general template we use to define and create specific instances or objects. Classes are often described as object factories. That is, the class is the general template, but it's capable of stamping out specific objects or instances of that class. And an object is an instantiation of a class. Classes are abstract, objects are concrete. An object is a specific concrete person, place, event, or thing about which we want to capture information. Now, let's look at methods first. Methods are sometimes called behaviors. They're sometimes called functions. They're sometimes called processes. They are really all the same thing. Methods are things that an object can do. And every object, when it's created, has two specific methods that are always there because they're necessary. They are insert and delete. And all that means is that an object you can create a new object, insert one, or you can delete an existing object, delete one. Okay, so that's what methods are. Methods are behaviors or things the object can do. Methods and behaviors are only triggered when they receive a message from some other object or class. For example, in this illustration, the class sends a method to insert a new instance to the patient object, which creates a new patient object. Okay, so these are behaviors. Methods are behaviors. Messages are the triggers that cause the behaviors to fire, as they say. Messages are sent from other objects or classes to evoke some behavior. Encapsulation and information hiding really are not hard to understand, and they are important. They're not critical. That is, what I mean is encapsulation just refers to the fact that processes and data are combined in a single entity, in an object. So an object has the attributes, that's the data, and the object has the methods, those are the behaviors or processes the object can perform, those are actions. Think of data as nouns and methods or processes as verbs. Okay, so encapsulation is an important concept to object orientation, and it came about because previously the data side and the function side were separate, and it made the process of analyzing, designing an integrated composite system difficult because you were walking in different directions. Okay, information hiding is a more abstract, esoteric notion. All information hiding means is that each object, each class you can think of it as a black box. It's got the information you need and it's got the behaviors you need, but you don't really need to understand what they are. You can send a message to a particular object to get it to perform some sort of behavior, but the behavior is hidden. That is, the specific method is hidden from the object sending the message to it. Again, it's kind of an esoteric idea, but think of the objects and classes as black boxes. Okay, inheritance. Now this is an important concept for sure. Classes are arranged in a hierarchy. You have superclasses, which are the top-level general classes, and you have subclasses, which are specific. We say that the subclasses automatically inherit all of the attributes and methods from the superclasses above them. Classes with instances are concrete. Classes without instances are not concrete. Let's look at inheritance in a little more detail. Okay, so here's a class hierarchy. At the top, this is a superclass, person, and the person will have certain attributes, a name, social security number, date of birth. But we can develop specific subclasses of a person, like doctor or patient. And doctor and patient automatically inherit the attributes of the more general superclass person, the name, the social security number, and the date of birth. A doctor has a name, social security number, and date of birth, but a doctor has other particular attributes and behaviors that are unique to the doctor and that the person doesn't have. For example, a doctor has some sort of medical license number. That would be an attribute. And a doctor can prescribe prescriptions, drugs. That would be a behavior. The person does not have those attributes. Person doesn't have a medical license, and a person can't prescribe drugs. Okay, same with a patient. A patient has name, social security number, date of birth, but a patient might also have type of disease or malady might be an attribute, and or symptoms might be an attribute. And the patient might have the behavior, make an appointment. The patient initiates making an appointment. The person doesn't have those specialized attributes and behaviors. So you can think of the more specialized class. They can do everything that the superclass can do, and then more. They're more powerful, not less powerful. And then so we can break it down even further. The doctor, there might be a general practitioner, which is a specialized type of doctor, and there might be a specialist, which is a specialist. Generally, only in this hierarchy, only in the bottom, the leaves of the hierarchy, here, here, and here, are there specific objects. You don't have objects, you don't have specific instances of the person or the doctor because they're not the bottom leaves. You only have specific instances with values for all the attributes and behaviors at the bottom levels, here, here, and here. So these are concrete classes, which means they have specific objects or instances. And these are abstract classes. They do not have objects or instances.